Hello grade 10. This video is about using tree diagrams. Your learning goals for this video are: first, you need to learn how to draw a tree diagram. Second, complete a tree diagram. And the third one is to use a tree diagram to solve conditional probabilities. This is just a continuation of what you have learned last week, the dependent and independent probabilities. So you need to know those events to be able to solve the problems that will be given here. Okay, so as I have said, tree diagrams are used to solve problems involving dependent and independent events. A tree diagram will also help you visualize of the problem. Okay, so given this problem, Peter has 10 colored cubes in a bag. 3 of the cubes are red and 7 are blue. He removes the cube at random from the bag and notes the color before replacing it. So he puts the cube back. He then chooses a second cube at random. Then he records it again. Okay, so here you can see that Peter did the choosing twice, so that means that there are 2 events. For the first event or the first choice, Peter can only get a red or a blue. And as given, you already know the probability of choosing a red. So there are 3 reds and then the total is 10. So the probability of getting a red is 3 over 10. And then for the blue, there are 7 blue cubes out of 10, so the probability is 7 out of 10. Now this is just the first choice. So this is the first branch of the tree. So we need to put the second one, the second leg or the second arm, and this is for the second choice. Okay, for the second choice, again, it could be red or blue on both cases. Okay, so I'm going to put it there. Okay, because Peter put the first cube back, so we know that there are still 10 cubes inside the bag. So there are still 3 red and 7 blue. So I'm going to put that as the probability on all cases. Okay, so now if we get the probability just like we did last time, it's multiplication. So the probability of getting a red and a red is 3/10 times 3/10 is equal to 9 over 100. And I will keep doing that for the rest of the branches or arms. So if it's a probability of red and blue, it's going to be 3/10 times 7 over 10, which is 21 over 100. That's the same as the rest. Okay, so you multiply. Now, let's take a look at the characteristics of a tree diagram. Okay, let's take a note that the end of first and the second level branches show different outcomes. Okay, and also that each arm or each branch of the tree, if you add them, you will always get 1. So 3 plus 7 is 10, so 10 out of 10 is 1. So if you look at this branch or arm, it's equal to 1. This branch or this arm is also equal to 1. Now if you go at the end, if you add all of this, it will total to 100 over 100. Okay, so these are the things that you would like to take notice of. Okay, and also the probabilities are multiplied along the arm. So you follow certain paths. Okay, so let's have another problem. Okay, what I would like you to do is read the problem, and this is similar to the first example that I have given you. So stop the video, do it on your own, and then when you're ready and you're done, play the video again and check if you have the same solution. Okay, here's the solution, here's the diagram, and here are your answers. Okay, so I drew the diagram, and that's for A. And then for letter B, I, it's what's the probability of 2 green beads? Okay, so I'm going to follow the path of green and a green. So green 5/9 times 5/9 should give you to 25 over 81. Now for II, the probability of a black followed by a green bead. So I'm going to follow the path of black. Black is 4 over 9 and green is 5 over 9. So 4 over 9 times 5 over 9 is 20 over 81. I hope you got the correct answer. Remember to learn how to write the appropriate symbol for the probability. Okay. Another problem is this one. Okay. I'm sure that it's getting easier now. So read the problem and do it on your own and check your work afterwards. The solution is in this video. Okay, here's the solution. Okay, and for the first question, 2 heads, it should be 1/4. And then for a head and a tail, or a tail and a head, it's 1/2. Okay? Okay, now, how about if this is what's given to you? Peter and Becky run a race and play a tennis match. The probability that Peter wins the race is 0.4 or 40%. The probability that Becky wins the tennis is 70% or 0.7. Complete the tree diagram below. Use your tree diagram to calculate the probability that Peter wins both events and that the probability that Becky loses the race but wins at tennis. Okay, so because they're playing 2 games, so the first branch is the race. We know the probability of Peter winning the race. So he has 40%. Even if we don't know what Becky has, because when we discuss about the characteristic of a tree diagram, we know that they should equal to 1. Okay, so to get the answer here, it's just 1 minus 0.4, and you should get the answer here. And the same way here, 0.7 or 70% is given to the problem. It says here that the probability that Becky wins tennis is 0.7 or 70%. So on the second game for tennis, if Becky has the probability of 70%, then that means that the probability of Peter winning is 1 minus 0.7. Okay, so remember that it's all about equal to 1. Okay, so let's complete the tree diagram. So here you go. 0.4 plus 0.6 is 1. That's 100%. 0.7 plus 0.3 is 1. And this has the same probability over here. Okay, so we already completed the tree diagram. So now we are ready to compute the probability for Peter winning both events. So here is where Peter wins. Here on this path, and then again on race 0.4, and then on tennis Peter wins and he has 0.3 or 30% of winning. So then his chance or probability of winning both events is 12% or 0.12. On the other hand, probability that Becky loses the race but wins at tennis is, here we go. So here when Peter wins is when Vicky loses, right? Okay, and so this is the path. And then on the other hand, Becky win, and so this is the path here. So 0.4 and 0.7, so you'll get 0.28 or 28%. Okay, so these are examples for independent probability. Okay, so now let's move on to dependent. Okay, now what's the difference? The difference is this problem is basically the same as the first one. But what happens is that when Peter takes the cube, this is the problem of a bag with the red and blue cubes. When he takes on the first one, he does not replace it. He does not replace the cube or put the cube back inside the bag. Okay. So that when we draw the tree diagram, on the first choice, you still have a 3 over 10 and 7 out of 10 probability. But because he does not put the cube back inside the bag, on the second choice, that means he does not have 10 cubes anymore inside the bag. Okay, so by then, on the second choice, you still have a red and blue. For the red, it's 2 out of 9 because you assume that on the first one, this is the case for the red. So there are only 2 reds left. So here, there are still 7, but out of 9 because the other cube was not put back inside the bag. On the other hand, the second scenario, it was on the first time, it was the blue that was taken away. So for red, it's going to go back to 3 out of 9. But for blue, because on the first choice, blue was taken, so 7 will change to 6 out of 9. Okay? So the probability of red and a red, again, you multiply, you 3/10 times 2/9, and you have 6 over 90. You continue multiplying just follow the path, and you're going to have your probabilities in 4 different events, okay, in different situations. Okay, again, look at each arm. They are always equal to 1. Here's 2 plus 7, 9, so it's 9 over 9. And over here, it's 100 over 100 if you add them all together. Okay, another problem, this is dependent, and I'd like you to try it on your own. Stop the video and draw the tree diagram and calculate the probabilities. Okay, just as a practice. Okay, we're back, and play the video again and check your answer and your solution. Here you go. So for 2 green beads, here's the green and a green, so 5/9 times 4/8, it should give you 20 out of 72. That's the probability. A black followed by a green, that's 4 over 9 times 5 over 8, so the answer should be 20 out of 72. Now, you need to have a tree diagram because it asks you to draw a tree diagram. Okay, I hope that you solved it correctly. And here's another problem as practice. Here's the chocolate and the sweets again, 30 chocolates. There's milk chocolate, dark chocolate. Okay, solve the problem and check and play the video again once you are ready. Okay, you're ready? So here's your tree diagram and here are the answers. Okay, so 2 milk chocolate. So you have this path, milk in a milk, so 18 out of 30 times 17 out of 29, you'll get 306 over 870. A dark chocolate followed by a milk chocolate, here's your dark, and then milk, 216 over 870. Now remember, the total outcome changes, okay? In the first branch, it's out of 30, and the second one, it's out of 29 because you don't put it back. Okay, well done. So now be ready for independent practices. Okay. See you in school. Bye.